Hello class, sorry I can't make it today. We're going to have a short, hopefully, video lecture about forces, pulleys, and systems. This is going to be a prep for a challenge problem that I'm going to give you. The point of this problem, you'll see, or you'll understand when you see it, is to make you struggle. You will not know how to do it right away, and that is in fact the point. You're supposed to struggle with it, work together in your groups, and eventually get it. But first, some notes. So if we have block A here, mass 5 kilograms, and it feels a force of 10 newtons to the right, what is acceleration? Alright, this shouldn't be much of a deal for you guys. We know that F equals M times A, or, if you prefer, A equals F over M. So this is going to be 10 newtons over 5 kilograms. Giving me an acceleration of g. What's 10 divided by 5? All right. Positive 2 meters per second squared. That's an awful 2 squared. Slightly better. Hopefully not a big deal. All right, well, what if it's vertical? Oh no, I don't know the force. I'm going to have to find it. Well, actually, no you don't. Because look at the block. What's the only force on it? The force of gravity on block B. Well, we know what the acceleration of that is. It's g. It's negative 9.8 meters per second squared. We didn't have to do any math to do that one. But let's say that we wanted to find the force, just for giggles. Alright, well, we would do 2 times g. Oh, wait, sorry, one thing. From now on, we're going to use g equals 10. So my acceleration is negative g, or negative 10 meters per second squared, which means that my force is going to be negative 20 newtons. Yay! Now we do that because that's what the AP asks you to use. I think it's silly, and I want you to know that the real acceleration is 9.8. But we'll be using 10 in class. Oh, now things are getting complicated. We know from our little thing that we just did that that's negative 20 newtons. But there's 10 newtons up. Oh no! How do we find the acceleration? Well, first I'd find the net force. Gee, what's positive 10 plus negative 20? It's going to be negative 10. And then find the acceleration using our equation from before, force divided by mass. And remember, that has to be net force. So that's going to be negative 10 divided by 2, giving me an acceleration of, what's 10 divided by 2? Oh, right, 5. All right, hopefully this is pretty simple. What about when they're tied together, though? So this is what's called a pulley system. We've got a table with block A sitting on the table. String from block A goes over the pulley and connects to block B, which is just hanging there. So when I let go, B is going to fall and drag A forwards. And I want to know, well, what's the acceleration of A? Well, that's hard. But here's a trick. A and B are tied together, which means they're going to move together. They're going to have the exact same acceleration. So I don't want to find the acceleration of A. I want to find the acceleration of the system. Now here's the really weird thing. And I'm going to say that the acceleration moves that way. A moves to the right, B moves down, but we're going to call that one direction. And we're going to call that, for simplicity's sake, the positive direction. Which means A is moving to the right, the positive direction. And B is going to move down, the positive direction. Okay, but how would I solve for the acceleration, Mr. Saslow? Hopefully someone asked that. Alright, well, here's a smaller picture, and I'm going to turn into a free body diagram by putting in my forces. I got 3 forces involved. I got the force of gravity on block B, going down. We have the force of tension on block B, going up. We have the force of block A going to the right. All right, let's solve this problem algebraically. How would I get the acceleration of my system? Well, the net force of the system is going to be the force of gravity on B, plus the force of tension, the one that's on block A, plus the force of tension that's on B. But notice how the force of tension on B is going up? That's my negative direction, remember, at least for this problem. So the net force of my system is FGB plus FT plus negative FT. So we can ignore those two. All right, the net force of the system is force of gravity on B. That's easy. We already know what that number is. What's the mass of my system? Well, that's going to be the mass of A plus the mass of B. We're not talking about just B anymore. We're talking about both of them. Okay, well, that's easy enough. We know what the masses are. You add them together. So what would the acceleration of the system be? Not 9.8, not 10. Because that force is not just accelerating block B. That force is going to be accelerating block A and B together. So my acceleration is going to be my net force of the system divided by the mass of my system. All right, well, what is that going to look like? Well, net force of my system, that's going to be 20 newtons downward from force of gravity. And then the two tension forces. I don't know what those are, but they cancel each other out, so I don't care. Now, why did I make it positive? Oh, right, because to the right and down is defined as the positive direction for this problem. Forward is positive. All right, what's the mass of my system? Okay, well, that's 5 kilograms for A and 2 kilograms for B, which gives me 7 kilograms total. Crazy, I know. So what's the acceleration of my system? Well, that's going to be 20 newtons divided by 7 kilograms, which gives me positive, because it's moving forward, 2.86 meters per second squared. Ooh. And that's it. You are now ready to get the Atwood's machine problem. On Echo, you're going to open the page called Atwood's Machine Challenge Problem, and you're going to work on it together in your groups. Now, what's an Atwood's machine, you might ask? An Atwood's machine is where you got a pulley with a block on one side and a block on the other that are connected together so it's hanging over the pulley. So when you let go, one block goes up and one block goes down. Ooh.